This week we're going to be sharing QA best practices, and we will be sharing with you not only some of the practices that Artisan has, but also some challenges that we have and some systems that we use as well. So our presenter today is Kristen Bruzek, and she'll be walking us through some thoughts. But from a high level, what we're going to be discussing today is this overall introduction to the team. We'll be talking about the different testing types and how we prioritize tests, along with automation, and then share some best practices and lessons learned. But first, a little bit about Kristen. She runs our QA team here, and as you would imagine, an extremely important job, as Artisan has released just not a number of new capabilities in a single product, our optimized product for A/B testing, but we've also released a number of complementary products, including Personalize and Analyze. And on top of those products, of course, we've also added feature functionality enhancements, and we've also added Android and iOS. So you can imagine the matrix, the responsibilities that the QA team here at Artisan has, and has just done a phenomenal job. So it's a real benefit to be able to have Kristen with us today, and for her to share with all of us some of the things that she's learned and some things that you might want to take back to your shops and employ yourself. So with that, let me turn the call over to Kristen, and we'll circle back and answer some questions. And if you do have any questions, please use chat and just send those over, and we'll try and get through as many as we can at the end of the presentation. And with that, over to Kristen.
Hi. All right. Thanks so much, Steve. So we're going to talk about some QA best practices. As you can imagine, and Dave mentioned, we have a bunch of different products, and working with mobile is always a tricky thing to manage and test. Within Artisan, we have some additional challenges, and I feel like the best way to be able to talk through our best practices is to talk a little bit more in detail about the challenges that we face that I think most of you probably encounter no matter what kind of software you're creating. The first challenge is that we have multiple components. So, we have a web UI, so we have a page that we direct everyone to, which requires really top-notch UI. It's got to be very usable for all of our users. It's got to be intuitive. It's got to be bug-free. All the kind of things that you would expect as a consumer to go to a site and be able to have it function the way you would expect. That's one portion. The second portion is we've got an SDK. So this kit we're putting into customer apps. And the problem with this is it has to be airtight. We cannot install our SDK and have it cause any problems on a customer application. That affects their end user, which would in turn affect their relationship with us. And we have some core principles that I'll talk about in a second, but our very first rule is we can do no harm. So testing our SDK, the level of expectation of quality is so much higher than anything I've encountered anywhere else, just simply because, with the type of customers that we have, they cannot afford to have any problems that aren't their own. They've got their own QA that they have to do, and they have to make sure their own apps are working as expected, and they just expect everything to be good on our side. To separate that out, we've got that for one whole kit for iOS, and then a completely different SDK for Android. So we've got two completely separate pieces that have to be tested completely into this totally separate code that have to function in a very similar way, but we have to make sure that both are working completely as expected. Then the third component is we've got something called an analytics platform, and what that is it's the ability for our SDK to go in and collect all kinds of data that our customer apps have customers doing. So, events that they're doing, creating funnel goals, all sorts of different metrics. Everything that you want to see about your app, how it's doing, usability, performance, things like that, we're tracking that all in. So just to expand that, some of the testing challenges are it's a lot of data that we're trying to manage. In addition, again, the type of customers that we're working with have an expectation of 100% quality. The numbers that we are providing out, they're expected to be 100% accurate all the time. And the more data you collect and the more data that you present, the harder it is to make sure that it's always accurate all the time. And forget about adding new features and making changes. The regression of that gets more and more complicated as you move along. The second piece is that, as I mentioned, our SDK is integrated into the customer app. So we work with a lot of enterprise customers, and their expectation is they want an SDK that's fully baked, that they can just put in, forget about, and go on their way, and just collect the stuff that they need to collect, make the changes they want to make, and not have any worries. We have to take all that worry on our side. So we've developed these core principles that we live by. Every single thing that we release into production, we say will do no harm. We will never cause an app to crash. We will never cause unexpected changes. We will never cause problems that the customer has to deal with. A second one is that we do not allow customers to see changes right before their eyes. So part of what we do is we allow customers to make changes to their app on the fly. Normally, if a customer wanted to make a change to their app, they'd make the change in their code, they'd have to resubmit it to the App Store, their customer would go and have to download the latest to be able to see the change. What we're doing is we're allowing the customer to make these changes and send it out to their customer base immediately. But doing that, we don't want a customer, an end user, to see a change while they're looking at a page. It's confusing, it's a bad user experience, so we need to make sure that anything that we're doing happens in a sequential order that's not presenting a problem. And then finally, a core principle is that we troubleshoot any and all customer-reported issues, even if they don't appear to be ours. So, one tricky thing about being integrated into customer applications is that we appear in every stat trace. Everything that goes wrong with anybody's app, our name pops up, and so we take it in, we sort through it, and we've provided good feedback on bugs that aren't ours so far. We've been able to say, hey, you've got this thing going on in your app. We looked into it. It's nothing on our side, and we've been able to provide good value from that. But the main point is that we have to take that inside and do all that research immediately to provide that level of assurance to a customer that we are doing no harm. Back to our first core principle. So, in addition to those things, we're ensuring backward compatibility for our own SDK. So we've released 20 versions over the last year and a half for our 1.x platform. So we had one product called Optimize that we've had out there, and we've released 20 versions of it. So enhancements, features, fixes, things like that we're guaranteed will not break for at least a year in the past. And then now we also have a 2X platform, which is adding in a new analytics platform and a couple of other new products that we're also guaranteeing is backward compatible at least for the last year. This is a lot of versions to maintain. It's a lot of backward compatibility to test. And then again, that's for iOS and also for Android. The last piece that makes this complicated, and I'm sure you all know personally, is there are so many devices out there, it's unbelievable. Between Android and iOS, whatever kind of device that you like, it's out there and we're supporting. We're saying to customers, whatever your app works on, we're going to make it work here. And so we have to make sure to do our testing on all of these different types of devices to ensure the quality that we're putting out there. That's a little bit about the challenges that we face. So to tackle these, we have a bunch of different types of testing that I'm going to talk you through and the importance of each one of them. So at a high level, we've got manual testing, which is pretty standard. We've got automated testing and a few different versions of it. We do UAT and usability testing and performance testing. And if you see the chart that's up on the screen, it breaks this down into some features that are more technology-facing, some are more business-facing, and then which pieces are more candidates to be automated, which is more manual, which can use some tools, and which aren't good candidates to use tools. So to go by and go through this step by step, let's talk a little bit about manual testing. So in today's world, there's such a big push on automation. Get everything automated, it saves time, it's more efficient. but manual testing is still really important. Here at Artisan, we manually test all features first as they're developed in the current sprint in an agile methodology. Then we move on to automating the backlog. This is really important for a few reasons. Manual testing gives you usability feedback. So the first feedback you get is from your own testers. If your own testers can't figure out the feature or make it work, then they're a problem. Automation can't do that for you. Exploratory testing. So manual testers go any which way they think of to be able to test something out. Automation, you pick one way and it repeats that same process every time. So you lose a little bit of that exploring and accidentally stumbling into a bug or finding a different way to execute a feature that was not initially expected. Another piece of particularly working in sprints and in an agile format is that currently you can manually test partial features. So if the back end is ready, you can go and test and make sure the database or the jobs are running and they're all connected while the UI is being worked on. Automation doesn't really let you do that. You need a fully baked feature to be able to automate it. So manual testing gives you the ability to test earlier in the process, find more bugs earlier, and potentially make a better quality product along the way. Automation can be expensive to maintain and create. It takes a resource to create the automation. As you build new features or as your product changes, you have to update your automated tests. It's a great tool. It's perfect for what it's for, but there is definitely a space for manual testing. One last piece is integrating multiple components. So integration testing is something that's really tricky to do with automation, especially if systems are fragile or if it's technically difficult to be able to automate that integration, or if you're required to mock up data, it takes away some piece of that integration testing that might create bugs that fall through the holes. And then additionally, speaking about bugs, automation isn't necessarily very good at retesting bugs. If it finds it, maybe it will test the one case that broke, but it won't be able to go through and test all the other edge cases around it. That's a little bit about the importance of why manual testing still should be part of any testing group. The next piece is automation. So we have three distinct kinds of automation here at Artisan. We've got your standard UI automation, which is basically just on our web page. We go through every single page. We make sure that all the fields, buttons, things like that are all working. The UI is perfect and pristine. It's one of the great candidates for automation. This one in particular is easy to maintain and update. A best practice around this is to build coding frameworks in so that automation can hook into. So the more UI type things you do, it's generally more fragile because if somebody just moves a button to a different part of the screen, it tends to break a UI automation. If you build these hooks in that you can hit the back-end coding features, then that makes it a little less fragile and it makes those tests last a little bit longer. It allows for functional elements to be tested without being as subject to design changes. A second piece of automation that we have here is the SDK automation. So as I mentioned, we've got this SDK that goes into partner apps that we have a really high standard of quality that we have to live up to. This is very, very difficult to automate. We have had actually to have a very experienced developer build our SDK automation, which includes a lot of just actual coding. But it does go through and it installs our SDK, it makes changes, it sees changes on a device. It's very expensive, but it's very critical to the development. And with our backward compatibility, with all the changes that we're making, it's so important to be able to have that confidence that our SDKs that we're putting out are accurate. The tools that we're using for this, so we've got a bunch of different pieces that are all working together. So we're using some Ruby code, we use a little bit of Java code, we're using an Apple tool called Appium. We're also connecting it through a Chrome driver, and then it's also using a little bit of Selenium. So it's pulling a whole bunch of pieces together just to be able to test the SDK portion of what we do. And then the third piece is that we believe unit testing should be fundamental to your culture. So here at Artisan, unit testing is part of every feature. It's considered in the estimates that we give, and every new feature has to have some unit testing or it cannot get past the approval process to be moved in. Other companies could use test-driven development or other sort of methods like that, or you can create them, after the code is done. But either way, it prevents code regressions and it allows for more confident refactoring. So if you know that you've got solid unit tests in place and you have to go in and refactor something, you can feel much more sure that the refactoring that you're doing is not going to break anything. The next piece is UAT and usability. And what I would say around this, and we take this to heart here at Artisan, is do every single thing you can to get as much feedback as possible. So we try to make use of beta launches, using partial features. During customer demos that we give, we keep careful track of the feedback from the sales team and the recipients of the demos, because everything that they mention to us can go into a feedback cycle where we can make it better and make our product better. And third-party integration. So every time we integrate our SDK, we take notes, we're careful, we go back, any bugs that we found, we make sure we get them tied up and release them out as soon as possible. And then the last piece of the types of testing and its importance is performance. So having a baseline and testing against that baseline frequently is completely one of the most important performance things that we have here. You can run performance tests all day, but if you have no idea where you're starting from or what you're comparing against, they're useless. The numbers don't mean that much. So making sure that you always know exactly what you're comparing to and having some goals to strive for is really important to managing how well you're doing on a performance perspective. It helps you analyze potential problems and impacts on a per feature basis as well. So instead of just performance testing your entire system, if you can do it as each new feature rolls out, you can quickly identify what the performance issue is and then help it. This is so important because what good is bug-free code that cannot support your customer needs? So if we've got, spotless code, but the minute a customer sends some traffic in and we go down, we're useless, right? It's as bad as if you have completely buggy code. And then performance problems are often the ones that bring down servers or systems that cause a lot of grief for customers. So every time there's a really angry customer, it's usually because they can't access us or we bring down their app because of traffic, and they're the kind of things that you want to avoid at all costs. So that's a little bit about the test types and their importance. So now we can go into some of the best practices that we have here. The first one is having common goals. So there's this concept out in the world about QA being against development and development feeling like QA is a blocker or slowing down the process. And one thing that we found here is it was really important to have the entire team on board with the role of QA and how we work together with development. So we have a list of common goals. This helps to speed the production and delivering the best quality possible. To do that, we have created a definition of done, which is also really important. Having the team agreement on it goes again with the common goal, and to display it prominently. So what you see on this slide is our definition of done that we've got right up on the board here, so that at any time someone can point to it and say, you know what, this doesn't meet our definition of done, it's not ready to go, we need to take further action. Included in our definition of done is that the feature itself is development complete, which is pretty standard. All acceptance criteria has passed. The story is finished on time to be fully QA'd, meaning development hasn't sent it over the wall a couple hours before it's ready to be released. You actually have time to go in and execute your testing. The feature has been fully tested and QA approved. This depends on your group and what sort of role QA has within the group. Here we have QA approval, so nothing can go out without QA saying that it's good to go. And then also that all critical and blocker bugs are resolved for that feature. So we make a promise that for any feature that we're pushing out, if there are any critical or blocker bugs open, we will not release it until they are closed. So some other best practices that we use here, feature demos and acceptance criteria. This helps to make sure everyone's on the same page. I'm sure you all, no matter what side of the fence you guys are on, whether it's development or even management or QA, you've all had times where there's been a feature and QA thought it was supposed to work one way, development thought it would work one way, business team thinks it works another way. Each person does their piece individually, and then at the end you've got something that doesn't meet anyone's needs. So having these feature demos right when the development is done helps iron out all those problems right from the start. It identifies all things that you can help resolve in a timely fashion to get the feature out the door. The same thing with acceptance criteria. Before development even starts, if you have this list of acceptance criteria to start from, the developers know where to work through, QA knows exactly what to test, and the business has given you the criteria that they're looking for, so you know that it will meet their needs. Another QA best practice is minimizing QA debt. So in a sprint fashion, it's really easy to have tasks run over the sprint. So, development didn't quite get done, so they're just going to keep working on it, and they'll work on it, like a couple more hours in the next sprint, and then turn it over. Ultimately, what that does is it creates a backlog for QA to get through, in addition to the new stuff that's going to be there in the next sprint. It's really hard to manage, QA debt that's coming in addition to the new QA features that are going to be coming. It creates rushing and some confusion, and one helpful thing that we found is the more that we can minimize this QA debt, the more tightly our sprints run and the better chance we have of having good quality at the end. So moving on to some other QA best practices are clean testing. So there's a concept in the development world about clean development, and briefly, that's kind of just going through that you have something you're developing, you've got your mindset on it, you keep it as clean as possible, you work through the main task, and then you can start working on edge cases and keeping your code clean along the way. So I've adapted that to a QA framework. And what that means is stay on track. So if you see other bugs as you're testing a feature, just jot them down, come back to it later. This way, you can get through what you're supposed to be testing, find all the things that you need to find, and then you can go back and see these other bugs. You can go back and retest them, and maybe they're completely unrelated that you just happen to notice. This way, it doesn't sully your results on what you're actually supposed to be doing. You can get things done, and then you can refocus on the bugs and be able to find them more quickly and easily and allow you to reproduce them. One additional piece to clean testing is don't try to troubleshoot until you've done all of your testing. So it's really easy to find a bug and say, oh, I think I know why that's happening. And you start digging in, and then before you know it, hours have passed because you've been trying to debug this issue that you just solved. Leave that until you're done. Find all of your issues, and then if you have time, go back and start debugging so you can provide better details on how to fix the particular problem. The next best practice is to regression test after a code freeze. This really helps to identify last-minute regressions, merging issues, or accidental code deployment. It's really hard to regression test on a moving target. So if you don't have a concept of a code freeze, and things are continually coming in, you're regression testing, but you're never really testing your code base as a unit. You're just testing new improvements along the way. This is how last-minute problems crop up. Sometimes when you merge things last minute or someone's rushing, they accidentally deploy something that wasn't quite ready. These are all things that happen if you can't have a solid code freeze, or at least an agreement among teams that, unless it's an urgent item, that it shouldn't go in until you've been able to do a full pass and make sure your product is hardened. The next item is a good test data / environment. So if at all possible, we try to test on the live production data. The way that we do it is we use a script that copies production data and we pump it into our test environment, scrubbing out identifiable information if there's anything personal to the customers that we can't share. Or we'll copy the prod database and just use that as our testing database. This is so important for finding data-related issues that we don't reproduce in local testing. Customers are always sending and doing things that are unexpected. The most crazy case you can think of, someone's sure to do it, and you really don't get to see that kind of stuff unless you're looking at actual live production data. This also helps you find deployment problems. So if you're running a script, but you're only running it on a test environment, you're not going to hit those cases that have weird production anomalies in them. So being able to run your deployment or load data into a production environment helps identify all of these things before you go to release it. And of course, I'm sure everyone would much rather find those problems early or resolve them and not at the time that you're trying to release, especially if you do, off-hour releases. No one wants to be up late trying to sort through, what caused this particular problem. And then ultimately, environment issues waste a lot of everyone's time. You know, you start going in and there are problems one after another because your environments are going down or they're not stable or there's not enough memory. You know, we struggled with this for a while here. You know, our QA environment was small. There really wasn't enough good hardware. And so, you know, we spent half our days fighting with systems being down. And so finally, we complained enough, you know, that we could get so much more done if we just had a solid environment that was much more production-like. And we got that, and things are like a world better. It allows us to get through testing so much more quickly than, you know, if we were just trying to struggle with it locally. Okay, so then the next set of QA best practices that I want to talk about is using a bug tracking tool. Use a tool to reduce duplication. It gives you a history and it allows you to prioritize things. I think most people use a bug tracking tool, but it's something that we use day to day. That's so important. Sticking to a plan, so shifting things around that can lead to confusion amongst developers and QA. So in your release, try to keep what's in the release to the release, because if things slip or you move things in, then people get confused, there's misunderstandings, and we struggle with that. Documentation. Do what is right. Do what is right for you. Don't be tied to these old ideas of everything has to be documented. You need step by step. It's an old idea that, in my opinion, it doesn't work for all companies. If you're a fast-moving company, your documentation is out of date almost as fast as you can write it. And then nobody has time to go back and update old things. So do what's right for you. Internally here, we don't do much test documentation because things are changing so often. And we're such a young company that we're constantly adapting based on customer feedback. So we document only what is necessary to be able to keep our knowledge shared across all people. And then finally, some testing guidelines. So what we've done is we've created a set of test guidelines. This is particularly important if you have junior level or non-career QA people testing, such as developers. Having some guidelines ensures that they're following the same approach as a standard QA person. You know, so if you have a shortage of QA time and someone has to step in and help out, at least you know that they're following the same sort of processes that you would go through, or it gives them some direction where to go. You know, just throwing someone into the fire and having them test something doesn't give you a great deal of confidence that, you know, you're going to have the right type of quality coming out in the end. And then make sure the testing story is prioritized. So if we have to have a developer test something, we do it in planning. We identify that we have a shortage on QA, and we pick a couple stories that we want our developers to test to help make up the difference. We'll plan it right from the beginning. We'll label it as developer tester ticket. This way, everyone knows that it has to be tested. It'll get tested in the beginning, so there's no confusion. There's no last-minute struggle. Oh, we have to quick test that before it goes out. And this way, again, you can ensure that quality is good. And then, so this final list of best practices is a little bit more on the development side, but it really helps to ensure good quality starting from the very beginning. And this is a pull request system that we have that goes along with a code review. And basically what that means is all developers, they create a local branch for their code, they build their code there. Before they can merge it in with the general development code base, the developer has to create a pull request. Basically what that does is it sends a note out into our instant messaging system that says, hey, I created this code, can someone go in and review it and make sure it's, you know, doing everything that we expect it to do? Then someone looks at it and they say, yeah, you know what, that looks great. You can have a squirrely. Squirrely is what we call it here. The squirrely says, ship it. Good to go. If there is some problem or they have some suggestion or something that the developer missed, it gets chompied. And we have a little animated guy that, you know, chompies the pull request. And that means the developer needs to take it back and make some additional changes, put it back out for a pull request and get it through. This sounds like it might take a lot of time, but in actuality, it really doesn't. And the small amount of time that it does take saves us on overall quality and problems that we could expect later. There are lots of good things that come out of doing this peer code review on a feature by feature basis. In addition to that, the development team has a few of their internal best practices on doing pull requests, such as anything with more than X number of lines of code requires an in-person walkthrough rather than just reading through it. or something for a really complex part of our system, like our SDK, for instance, will generally require a much more thorough review, and someone who feels like they've got an expertise in that is the one really who should do it. So, but again, like I said, this really helps to ensure good quality code and that scenarios aren't missed before it even gets to QA. And that makes the QA job easier, and we can be more efficient in getting more things done. So, in summary of all this, all of these things combined we try to use together to create a really smooth running development lifecycle process that in the end we've got good quality code that's coming to QA. QA knows exactly what they're supposed to be looking at. We can test it, we get it cleaned up, we can send it to the business teams for usability feedback. We make sure everyone's on board, and then by the time we get to release night, we have full confidence that all things are good and set. And, a release is no big deal here. We pull the trigger, release is out, and we're ready to go on to the next piece. So that's all I have. That's the summary of the testing challenges that we have here and some of the best practices that we follow. So I'm going to turn it back over to Dave for any questions.
Wow, we got a lot of questions coming across during this webinar, Kristen. Awesome job. And I know we're running a little bit longer, so I'll just try and get through 3 of these as quickly as possible so folks can get back to their day. The first one is, if you don't fully document your tests, how do you ensure functionality is documented, and what happens if someone that doesn't understand the feature has to go back and then test it?
Good question. So how do we just ensure that there's knowledge shared and that it stays up to date? Well, we've got these wiki pages that we keep for good to know, so we constantly are updating that with things that you should know about a feature, and that does stay updated. And in addition, if there are features that are particularly complicated, we do document those. So things that would be trickier or that someone might struggle understanding, we make sure to have those down and keep those current. It's just the smaller things that would be easier to figure out on their own that we don't spend the time on.
Cool. The next one is, how do you make sure there's enough time to do adequate testing per sprint?
So the way that we manage that is we estimate our QA time in the sprint planning. So we have developers estimate their effort, and we'll estimate the QA estimate at the same time, and then we'll reconcile it at the end if the features if they can't usually fit within the QA bandwidth, we'll start pulling things out to make sure that everything that comes out can be fully tested.
Great. And the last one, before we let everyone go, do you do any sort of metric reporting or analysis on bugs that make it to production versus the ones that are found during general release testing?
Sure. Good question again. So we use Jira as our bug tracking tool, and that has a lot of built-in metrics that we try to take advantage of, and part of that is that we can track exactly which bugs were opened before release, which bugs were opened after release, which ones are reported by customers. So this way we can track exactly which ones are found in production, what's open out there, and what's found during our normal testing process. And that helps us get better and find ways that we can be more efficient and ensure good quality.
Great. Well, that's it. And thanks for everyone for staying on. I see that actually everyone stayed on through the entire webinar, even though we went long. I think that's a testament to the great job that Kristen did for all of us today. So with that, thank you very much. Next week we'll be going over advanced analytics, segmentation, and personalization. So I look forward to speaking to everyone then. Thanks a lot and have a great day.